Am I audible in the back? Yeah, looks like. So, good afternoon, everyone. What were we working on in the last class? What did we do in the last class? Function analysis. What did we cover before that? Cause effect chain analysis. So, what is cause effect chain analysis? A model or a method, I would not use the word model, I would rather use the word method to identify the root cause of a problem. The problem we call as initial disadvantage, and the root cause we call as the key disadvantage. Where we go, we'll ask many whys. We ask first why, second why, third why. We go on asking whys, and we go deeper into the problem. And we say, okay, we have identified the key disadvantage. Once we reach where? Once we reach a limitation of physical, geometrical, chemical, biological, some such characteristic, limitation, parametric things. Once we reach there, we say, or in one case also user specification, user requirement. But ये तो user requirement है. So that is what is called as the initial, or that is called what is called as the key disadvantage. And this is what you would typically also do in the 5 why process, and you would call the key disadvantage as what we call as root cause. And you say this is the root cause of why this happened. But a fishbone diagram, and something similar you do in the fishbone diagram where you say, okay, this happened, or this happened, or this leads to that, all that. This is the reason why this happens. Fishbone diagram also tries to do something similar, but those are linear in nature. Whereas when we come to cause effect chain analysis, we're talking about logical operators also coming into picture, where we say that there is an AND operator or an OR operator, and there could be multiple reasons because of which a failure can happen or an initial disadvantage may appear. And by going through the chain of intermediate disadvantages, you can now choose which disadvantage or which problem to work on, to solve, so that you are able to finally handle the initial disadvantages. So we also talked about this statement that for every 1,000 hits on the leaves of a tree, 1 hit on the root does it all. So if you identify the key disadvantage, it may happen that all the initial disadvantages linked to a product can be handled with just handling just one key disadvantage. But it may not be the case. Many times it may be that इतनी सारी चीजों को अलग-अलग solve करना सही नहीं था. I find the key disadvantage, I solve that. That is one possibility. But it may happen that that one key disadvantage is such that you cannot do nothing about. What do you do then? You identify in the intermediate chain, where is that disadvantage that is easy for you to handle. It could be based on your skill. It could be based on the context in which the problem exists. It could be based on a wide number of, or a very varied number of factors. But what we are essentially looking at is that now I get to choose where to hit, which problem to solve. Choose which is the easiest problem to solve, which is the cheapest problem to solve, where is the solution most effective. Are you able to see this? We did that small exercise ourselves, and in that process itself, we could see that जो problem otherwise बहुत untenable लग रही थी, which was very difficult to even get a complete hang of, Just by doing the CEC analysis, we got much more clarity about the problem. And also ideas came, oh, I could solve it like this, I could solve it like that, I could solve it like that. Is it not? So while this is not a problem solving tool, it is still a problem identification tool, it can still lead to some idea generation. We're not valuing those ideas yet, but at least a variety of problems are now available to us and we can see how to handle them. Is that okay? So cause effect chain analysis we did in terms of engineering systems, which we know something about. And at that level itself, if we are able to solve a problem, we are able to go ahead, do it. But we also saw that for some of you, even though this process was happening, there was not clear understanding of how the system is working. And therefore, will the solution that you propose or the problem that you are identifying, is it really genuine, right, or not? And that was where we started on the next step. What is the next step? The next method of problem identification is function analysis. We saw that function analysis has 3 steps. First step is component analysis. Second step is interaction analysis. Third is function modeling. In the last class, we entered into the domain of component analysis. So what is component analysis? In component analysis, we start with the definition of what is the engineering system. What is an engineering system? Any system that with that we can apply any engineering function. Yes. But in the context of the problem that we are solving, an engineering system is that system where we want to do something for which we are responsible, for which we need to tweak, correct, innovate, invent, so that the initial disadvantages or the problems with the system are resolved. Are you with me? So you will notice that now we are entering into that zone of the course, jahan pe the fluff is kind of vanished. Now we are talking about keywords and technical terms. Engineering system has one definition, and if you use English to understand engineering system, that will be very different from the definition that we use in this course. So अब आपके एग्जाम में, क्विज में किसी जगह पे अगर सवाल आएंगे, तो आप चैट जीपीटी के आंसर्स नहीं लगा सकते. Are you able to see this? Because now the lexicon is completely different. This lexicon, ChatGPT doesn't understand yet, because not many people use this language. So it is extremely important that you stay alert and make notes wherever the need is. The videos are also available for this particular course. There's a playlist that is also available on my YouTube channel. But I can assure you that what you can get in a live transmission, you'll only get 10% of it in that YouTube channel. Okay. So those videos exist. You can watch those videos also. But over here, we are interacting and discussing and clarifying doubts. So it's important that you are around when we are discussing these topics. Because I see many faces, they are treating it like any other course. It is not. I'm telling you, it is not. You will not find anything of this course online. Those YouTube videos of mine are there, but then अगर मेरे YouTube videos देखें तो class में आ जाओ ना. So and those YouTube videos are a little old, dated. There is a different flavor and the way in which I am handling the same content when I'm doing it now. So we may discuss something in class which is not there in the videos, and you may miss on that and struggle when that thing is asked in the quiz or in the mid-sem or end-sem exams. So it's important that when you are committing to this course, you are committing for attending the sessions, all the sessions. Okay. So Engineering system is the system in which I am going to make some change. The context in which this engineering system operates is called as super system. We discussed the example of that water bottle and we said, depending on the problem that I'm solving, water can be a super system component or it can be an engineering system component. Depending on the problem that we are solving, gravity could be required, or gravity may not be required to be a super system component, because we discussed that super system is everything. The sun, the moon, Saturn, Jupiter, everything is super system. Now, if you were talking about astrology, then all those are key elements that you would want to put into your system. But when you're talking about जो दिल की बात हो रही थी, तो हो सकता है ही से तो कुंडली का असर है, तो वहां पे we will bring those things in, or we say no, that has nothing, no bearing on it. Why should I talk about how did the information leak out of this room and then talk about Saturn and Jupiter there? You see? So super system can have everything under the sun. Under the sun, nahi, beyond the sun also. Everything in the universe is super system. But what do you need to model? You have to be very judicious. You cannot keep everything because it is too complex, but you keep too less, and the solution space that you will arrive at later will reduce. Okay, so you have to strike a balance. Okay, how do you know where the balance sits? No, you do not know that yet. You will learn that with practice. Practice that you will do in the classroom, you will be expected to do on your projects, and also during the exam, you will be solving some new problem there. Okay, so but if you've not done the practice in the classroom and in the project, the mid-sem or end-sem exam will be a bummer for you. You will not know what to do now. Okay, so we have to choose components carefully. We discussed that the first step in doing component analysis is creating a hierarchy of components and agreeing or deciding which hierarchy you want to operate at. Any component analysis cannot have system components across the hierarchy. As you move the hierarchy, those components will become super system components now. For example, we took the example of a car and the alternator battery charging system. If you're talking about that, then steering wheel cannot be a component of your system. It can be a component of your super system. But if I was talking about the car itself and the car assembly plant, then steering wheel was a part of my system itself. But if I was talking about the electrolyte in the battery, then even the alternator is a part of my super system. Are you able to see this? Whether I model it or not, I don't know. But it is a component of the super system. That thing is clear. That system components all have to be at the same hierarchy level. Super system components can be at whichever level. Is it okay? Then, as I said, we have to filter them for relevance. We took one example of paint filling system. We'll use that example over and over again in this course. We'll use that example when we do function modeling. We'll use that example when we do trimming. So you better be well versed with that example. Do you want me to refresh that example for you?
Yes.
So we were talking about this factory in which radiators were getting painted. What are these radiators? These are those appliances कह लेते हैं, कुछ भी कह लेते हैं, which cool the engine of the car. They're placed in front of the engine. As the engine heats up, the coolant in the radiators carries the heat away and the fan throws that heat out. Now, electric cars don't have it, but internal combustion engine cars have it. All vehicles of which have internal combustion engine have some fan kind of a mechanism to dissipate that heat. So these radiators have to be painted. There's this factory in which there's a big tank. Radiators come on a zip line. They take a dip. They stay in the tank for some time. And after some time, they go up. And by the time they exit the tank, they are fully painted. Now, because radiators keep coming and going, some paint, obviously आपने radiators को paint करना है, तो paint will reduce. The paint gets reduced, and then you have a pump, a system which measures a float. It has a float. It sees that, okay, the level of paint in my system has reduced. The tank has lesser paint than what I need to dip my radiators well. And I should turn the how do I put it? Pump on. And when I turn the pump on, the barrel is there, pump transfers, the motor runs, the pump transfers the paint from the barrel into the tank. Simple system. What was the problem? The problem was that the float, because it was dipping in the paint, some paint was also solidifying on the float. So the float would become heavy over time. So just time पे float को pump को बंद करना था, the time when the float had to rise sufficiently to switch off the pump. Now that time is delayed because the float is heavier. It's not really a float now, it's a little heavier than the regular float. And धीरे धीरे करके the level at which the pump is closed rises. And then there comes a time when the next morning when you're coming to the shaft floor, the entire shaft floor is yellow in color. Because what happened? The float was so heavy that it did not communicate to the pump that it has to turn off. And the pump continued to pump more paint, and that spilled over, and everything is paint now. So now the entire assembly line halts. There are car bodies which are getting ready, but now they are halted because the radiator is not ready. Why is the radiator not ready? Because the painting facility has this spill, and now you want to stop that radiator painting facility for 2 days, clean the mess up, change the float, do everything right again. So 2 days, cars are piling up, the entire production line is halted. Huge loss. Not acceptable situation, so we want a solution. There could be sensors you could use, there could be complex stuff that you could use, but that is not allowed because they have their own maintenance issues, they have their own reliability issues. We want something which is simple, which is more mechanical, no energy requirement, no high-tech sensors, because then I need to hire electronics engineers also. All of you EC and EV people, electronics engineers, no, we don't want to hire electronics engineers. I want a solution which I can handle in my mechanical factory by myself, by the engineers that I have within there. So no such funky electronics, AI stuff. That is the problem, or that is the constraint in which we have to find the solution. So we did the component analysis and we listed that, okay, in this, which are the engineering system components? The float, lever, switch, motor, pump, barrel. Which are the super system components? Paint, tank, radiators, air, gravity. And then we also identified the target. What is the target in a component analysis? Target is the object or the component for which the system exists, the function exists. The target of this component analysis is the radiator. We discussed that when in this bottle, I have to maintain the temperature of the water in there. The target of that system is water. So the target can be very, very different things. But in the same bottle, when I was talking about a kid-friendly thing, then the target could be that the floor should remain clean. The floor should remain dry. The target could be floor. That could be my problem statement. Is it not? So targets can be different for the same engineering system, depending on which function you are trying to model, which problem, which initial disadvantage, which problem you are looking to solve. Is this okay? Shall we take one more example of component analysis now? Let's say there is a hair dryer. I want you to do a component. So this is how it looks. I want you to do a component analysis of this hair dryer. Quickly, do it. So in component analysis, first thing you do is list down all the components. Then you identify which are system components, which are super system components, and which is the target. So for a hair dryer, what should it be? आप करो, सब लोग independently करो. Take 3 minutes. Write down components at the system level, components at the super system level, and then also identify the target for me. If you don't practice now, I'm telling you, it's going to be trouble in the mid-sem exams and sem exams. So please do. Done? Please take 1 more minute quickly. Done, everyone? Okay. So what did you guys put in the components of the system? I want system components first. Then we will look at super system components. Motor. एक मेरे को लिखने दो, उसके बाद नया शब्द बोलो. Motor, fan blades, okay. Wire, coil, switch, कॉर्ड, रेजिस्टर, ये वायर कॉइल अलग है क्या? सेम तो है. ओके. कंट्रोल सर्किट. ओके. Blower is this fan only, na? Okay. So, is this component analysis correct? Check. Are all the components at the same level of hierarchy? He's saying switch and cord can be super system. Okay. He wants to put them there. Okay. What else? Power source also here. Power source मैंने लिखा ही नहीं था. चलो यहाँ पे लिख देते हैं. And any other views? Air. Air कहाँ है? System है? Super system? Super system. Air. Okay. Outer casing of the, okay, enclosure. Okay. Very good, Pritha. Until you know what is the problem that you are solving, will you even know what the target is? That is your assumption, na, Tushar? Yes, but the problem could be that it is not convenient because the wire is too short. What will be your target then? But if the problem is that it doesn't dry my hair quickly enough, what is the target then? Then the wire doesn't have any role to play in it. Do you see that? So until you understand what is the problem that I'm wanting to solve, can you do component analysis? No. So until you have done CECA, can you go here? Or forget about CECA. At least the first semblance of the problem, the first thing should be what is the problem that I have assumed? Is it not? For someone, the problem could be it consumes a lot of energy. Then, what would be the target? Oil, probably. I don't know. It could be the fan. Fan is where energy is getting consumed. I don't know. So until you know the problem, will you know the target? Will you know which system, which parts are system components, which are super system components? And you see all of you rushed into solving the problem. That is what happens, or that is how badly our engineering education system has misaligned all of you. कि सामने वाले ने कहा कि वहां भागो तो सब भाग पड़े. पूछा भी नहीं क्या करना है, वहां से क्या लाना है, क्यों भागे वहां पे. Are you able to see this? No, this was not the lesson that I wanted to teach you, but आपने मुझे मौका दे दिया. देखो, those of you who've done other courses with me, you know that you will enter into, in this class, you will enter into those zones where I'm not talking about the course at all. I'm talking about stuff. I warned you about this in the first lecture, by the way. But अभी आपने मुझे मौका दिया to point out this one thing to you, that when you set out to solve a problem, there is a method to it. But first of all, the first part is to identify what the problem is. What is it? What is the challenge that I am facing? What is it that I want to achieve? Until you know what you want to achieve or where you want to make an improvement, you cannot do component analysis. So उसने कहा कि इसको वहां डाल दो, मैंने वहां डाल दिया. Did I say no या yes? No. The problem that he wanted to work on, it could be a part of super system. Problem that Anushri wanted to work on, it could be a part of system. Now, which answer is right, which is wrong? It clearly depends on what is the problem that we are solving. Is it okay? So I can play such tricks with you in the exam also. Be careful. Because then every answer is wrong. सर आप तो मतलब सैडिस्टिक होते जा रहे हो सर. आप तो मार्क्स काटने के पीछे ही पड़े हो. No, but that is a very important lesson that you have to learn when you go ahead and do some problem solving. You may know the entire method, but if you do not do the basic stuff, then it's not right. And I was waiting, सारे बताए जा रहे हैं. I was waiting कि कोई तो पूछे, what is the problem? And then she asked. So thank you, good. Until you know which problem I want to solve, can you make the do the component analysis? No. So okay, I also did some uh, component analysis in which I said, okay, body, power cord, heating element, fan, nozzle, motor, everything is system component. And I said, air, user, water, and here, they are super system components. Okay. So what was the problem I'm trying to solve? I'm not telling you this yet. But I said that, okay, all these, if I keep them in the system, whether it is the problem of my hair dryer not being in the wire being short or something, whether it is that kind of a problem, or whether it is too slow, too power hungry, whatever is the problem, I will be able to handle it. The other side are clearly super system. Is it not? So what is important to understand is that all the components that you put, all the system components that you put, they have to be at the same hierarchy level. I asked you this question over here because I noticed that someone is talking about blades of a fan and someone else is talking about the entire blower. Clearly, there are two different hierarchy levels. Are you able to see this? So I thought that someone of you will point out to that aspect, but I'm glad that she brought in the bigger aspect, elephant in the room, she touched upon that. So this is wrong simply also because there are two components at different hierarchy levels. Control system has been brought in, whereas we're not even talking about, हम उसको heating arrangement की बात कर रहे थे. Control system is like talking about electrolytes when you're talking about battery charging system, alternator ke level pe. Is it not? So when you change the hierarchy level, answer is clearly wrong. But in this case, all answers would be wrong because आपने पूछा ही नहीं कौन सी problem. है ना? So the super system component that I have identified, why did you not identify the user there? Can a blower operate without a user? I did not show it to you visually in that image, but does that mean that the user is not around? You will realize that many times you will be able to offload some functions to the user very conveniently because they're doing something anyways. Instead of carrying the burden of doing everything by your system, if there is a user, they can do one more thing. You're taking away 10 things from their head, give them one thing, they can handle it. User is a very key resource. None of you talked about water. Water ही तो उड़ाना है ना उसको. Hair dryer, why is it used? Because water has to be evaporated. Water is the target, actually. What were the targets that you people had identified? Heated air is the target, huh? Drying, no, that is a function. Target is a component. Dry hair, hair is the target for you. Motor is the target for you, okay? Target, component. Target is a component. I'm not talking about the goal of the program. Hot air, hot air. But is the purpose, is that really the purpose of a blower, of a hair dryer? See, if I was talking about a room heater, that is the target there. But I'm talking about a hair dryer. The target is water. That needs to be evaporated. Is it not? Hot air is a means. If I can do something else, it would be fine. Is it not? Why does the user use a hair dryer? To remove water from their hair. So this nuance is extremely important. Because till the time you say that the hot air is the target, you will never be able to come out with a latent PV and a solution which is out of the box. As we will progress, you will see that when we'll do trimming, we'll arrive at a solution which is nothing to do with hot air, but does the job. Because I identify the target as water. Are you able to see this? So this requires a little bit of design thinking. Why is the user using it? Entering into their shoes and trying to understand what is happening there. Then things happen. See, if you really want to do something as Steve Jobs did with the phones, then you cannot talk about hot air as the output, as a target. Then you have to talk of water as a target. Is that okay? With hot air as a target, you can improve the system a little. But with water as a target, you can bring about a transformation. Any questions? हाँ, बट अगर आप वाटर लिखोगे ही नहीं सुपर सिस्टम में तो उसको टारगेट कैसे बनाओगे? See, whatever is the target has to be a part of the super system. Okay, so one rule is target cannot be a component of the system. Target has to be a component of the super system. ठीक है? So जब हमने bottle की बात करी थी, when we were talking about the bottle, and we said that I want to maintain the water in the bottle at, say, 29 degrees Celsius, even though the outside temperature is 2 degrees Celsius. So water was the target. Water is not a part of my bottle. Is that okay? Any questions? The target there would be paint or the float. Why does that system exist? Does that system exist for the paint, or does that system exist because I want to paint the radiators? But there the target would be radiator. Yes. Because I want to paint the radiators. That is my baseline. Do I need the tank? Is the tank necessary? If I can paint the radiators through spray painting, is the tank necessary? But I still want radiators to be painted. Tanks can be removed. Barrel can be removed. Everything else you can remove. Paint you cannot remove. Paint is what you have to do. But radiators have to be there. Radiators are what are the system, are the thing that you need or what you need to act on. So the entire system was built to act on radiators so that the radiators get painted. The hair blower, the hair dryer is made to act on the water inside your hair so that the water gets evaporated. Now, if you were looking at the hair dryer as a styling machine also, that it would style my hair, then the target would be hair. But you did not say hair also. The air is a super system component that I'm not challenging. But what is the target? आपके सुपर सिस्टम में अगर टारगेट लिस्टेड नहीं होगा, how will you solve the problem? Are you able to see this? You had a question. Yes, something for which the system exists. So if I have to style the hair, you need the hair. A Taklu person will not use the hair dryer to style the hair because there are no hair. Now, don't look at me. Sorry? Yes, the goal could be I want a hair dryer which does the styling well.
My target is achieving a dry hair.
No, so that is where you need to realize that the language we are using here is very specific. Okay? We are not using English here. We are speaking in English. The terminology also appears to be English, but the meaning is very different. Are you getting it? So, those who know two languages, say Hindi and Punjabi or Hindi and Tamil and all like that, you will realize that there are many words which sound exactly the same, but they mean very different. So this is like that. You're learning a new language here. This is a very big risk that you will confuse with the terms. That is why it is important to be in the class and clarify these things. Because otherwise, when I will ask you this question, you will say, no, the target of my project was to gain that. No, I'm not talking about that target. That is the goal, that is the objective. I'm talking about the target component on which your system should act. So this, as I said, this is very precise because it's something like this. Chemical equations all of you have written. If instead of CuSO4, I write Cu plus 1 and SO4 minus 2, I've changed stuff. That not? So when I'm talking about copper sulfate, it's either CuSO4 or copper has two valencies, 2 and 3, no, 2 and 1, or Cu2SO4. I need to know whether it is CuSO4 or Cu2SO4. I will call them both copper sulfate only. So when you learn a new language, you have to learn the terms clearly. Tabhi I am spending so much time on the definitions. I'm asking you what is an engineering system. We are deliberating on what does a system mean to you. Because this is a new language. And there's a very high probability of you getting confused. Is that okay? So target is not the goal, not the objective. Target is which component do I want to work on. Is that okay? Any more questions?
Yes, sir. We can also use hair dryer not to dry our hairs, but also as a heater.
So if that is the case, then you are not talking about a hair dryer. You're just using it like a heater. You're talking about a heater. And then I already said, if you're talking about the room heater or the blower, then hot air is the target. Fine. Is that okay? A radiator and paint both are super system components. A radiator definitely is, paint no. So in the component analysis that we did, in fact, Paint also is super system because paint will come and go. Paint, tank, radiator, but target is radiator. So water, for example, is a super system component in the bottle. Is that okay? So revision. What is a component? An object, which could be a substance, a field, or a mix of substance and fields. Okay? Which is a part of the engineering system or its super system. What is an engineering system? A system that has been assigned to perform a function. What is a field? It is an entity without rest mass that transmits interaction between two substances. Substance is an object with rest mass.
So what do we mean by rest mass?
Rest mass means that if left as is and you weigh it, there will be some mass. Okay? And super system is the system that contains the context in which the analyzed engineering system operates. These are very important keywords. We will use them like this. Is that okay? रट्टा नहीं मारना, आप अगर समझ लोगे, that is good enough. But it's important to understand that the language is different here. The words are appearing to be English, but their import, their message is very specific in the language of inventive problem solving. Is that okay? So now, with this much on the component analysis, we move to the next step. What is the next step of function modeling? Interaction analysis. So, what do you mean by the term interaction?
Components interact.
I am also interacting with you. I'm interacting with you, am I not? We are interacting. What do you mean by the term interaction? In English first.
To have communication between two things in any way. Transfer of information.
So transfer of information that could be wanted. So it's communication, unwanted, it is interference. But something, some touch is there, some contact is built, and then something happens. So in the language of TRIZ or inventive problem solving, interaction analysis is used to identify. Interaction analysis is a step which is used to identify the interaction of the components of the engineering system and with each other and with the components of the super system. I will read it out again. Interaction analysis is used to identify the interactions of the components of an engineering system with each other and with the components of the super system. And one thing that you need to very carefully notice is that interaction means touch. There has to be some contact that has to be established for interaction to happen. When we are interacting with the sound, we are interacting with the sight. So interaction is happening. There is some contact that is built. Is that okay? Now, we are, let us say we are sentient beings, so we can understand each other with this common conspiracy called language. So we are creating a new conspiracy here now. So I shared, language is a conspiracy. I shared with you. So language is a conspiracy, and now we are creating a new one. So when we talk of interaction in this new conspiracy that we are creating amongst us, there has to be a touch. Okay? If I'm not touching you, I'm not interacting with you. That is what we mean in this particular lexicon. Is that okay? So यहाँ पे English से फर्क है. So what does interaction analysis require? Interaction analysis requires us to build a table where on the x-axis, on the first row, on the first column, we put all the components. Repeat them in the same sequence. So component 1, component 1, component 2, component 2, component 3, so on. And then component 1 obviously is component 1. How can it? It will always touch component 1. So the diagonal is shaded, blackened out, whatever. Is that okay? And then if component 1 and component 2 interact means they touch, then I will put a plus sign. If they do not touch, I will put a minus sign. It's as simple. If two components touch, I put a plus sign. If they do not touch, I put a minus sign. And I do this for both the halves. I look at component 2 and check if component 1 touches it. And I look at component 1 and I look at does component 2 touch it. So the entire matrix has to be filled. You can go row-wise or you can go column-wise, but you have to fill every cell with a plus or a minus. Then, once you've done that, you do a sanity check. What is that sanity check? Now, this matrix should mirror along the diagonal. If A is touching B, then B is also touching A. So if I have put a minus here, then this minus should be here also. If I put a plus here, then this should be a plus also. Are you able to see this? When I'm talking about component 3, I'm checking if component 3 has an interaction with 1, I say plus. Is it touching 1? Yes. Is it touching 2? Yes. So I put a plus in both. हो रहा है ना? तभी मैंने यहाँ पे जब 2 आया तो यहाँ पे प्लस लगाया, कंपोनेंट 2 के सामने 3 आया तो मैंने फिर प्लस लगाया. Are you able to see this? Any questions? So it is very simple, is it not? Very simple? Very simple. क्या प्लस माइनस तो लगाना है, ये तो आपने कब सीखा था केजी में. यू डिड प्लस माइनस इन केजी नहीं. सर क्या सिखा रहे हो, प्लस माइनस करवाना सिखा रहे हो सर. लेट्स डू इट देन. धनुष इज लाफिंग कि जिस तरह से बता रहे हैं, इट्स नॉट एज सिंपल एज इट अपीयर्स टू बी. So no, it is not as simple as it appears to be. The way you will do interaction analysis will have a very strong bearing on the solutions you will arrive at finally. Okay, and you will realize that there are so many assumptions that you will make about things that you are making so many assumptions about engineering systems that that is where you're not able to find solutions. Okay, so let's take the paint example again. This is the same figure that we have, and let's do a interaction matrix for that. Let's build an interaction matrix for this. You want to do this once independently? Please do. It's very simple. Won't take long.
Like touch means like physical.
Physical touch.
Air doesn't touch to
Hot air touches hair. You blow the hot air actually goes and touches hair. Your dryer doesn't touch hair. So dryer doesn't interact with the hair at all. Dryer interacts with hot air.
yes, yeah, example. Air motor. Without motor, fan cannot rotate. Rotate passes air evaporates all that. So there's a connection. But
Yeah, yeah. Yeah. So you have to say that you list down all the components and you would say air touches the blower. Air touches the heating coil. Air touches the body of the blower. Whatever components you've listed. But does heating coil touch fan? No.
so here we have to take all the components of the multiple engineering system. So any particular
Interaction analysis includes all the components of your system and your super system. मैंने कहा ना, it talks about interactions that are happening between the components of the engineering system amongst each other and also with the super system. It lists down all the components of the system and the super system and then build this interaction matrix. So you want me to show you the component analysis of the system once again? Will that make it faster for you? So this was the component analysis that we had done in the last class. Sorry? Ah, all the components, whether they are system components or super system components, you have to consider them. Because paint moves ना, paint तो आ रहा है system में जा रहा है, paint तो consumable है ना इसमें. It is not a part of the engineering system that paint could be considered as a target of the pump, for example. Barrel component है तो tanks भी components होने चाहिए. हाँ, you can put that. हमने नहीं डाला था, डाल दो. डाल दो. Feel free. Components are on X and Y axis. यहाँ पे switch 1 लगाओगे तुम. 1, 2, 3, 4 लिख रहे हो. You're saying switch and motor and tracking. इस तरह से करना चाह रहे हो. You actually write the component names here. It will become easier for you. ठीक है. You can the way he's doing. क्या? डायग्राम दिखाओ फिर से. या मैं कोई चीज दिखाता हूँ, तुम कहते हो दूसरी चीज दिखाओ, फिर पहले चीज दिखाता हूँ, फिर कहते हो दूसरी चीज दिखाओ. इसको ब्लैकआउट कर दोगे. Is pump touching the barrel? Okay. पेन तो सब को टच करेगा. इसमें यूजर क्या कर रहा है? इस सिस्टम में नहीं है. ऐसे हमने फ्लोट लगा रहा है, यूजर ही करना था तो कर ही लेता हर बार. बट इंजीनियरिंग की जरूरत कहाँ थी? हाँ, ग्रेविटी तो सबके साथ इंटरेक्ट कर रही है. डाल दो. काम तो कर रही है ना. Take another 2 minutes. Close quickly, please. How many of you have done it already? Okay. The rest of you, please take 2 minutes and close. Sorry? All the system components have to be at the same level of hierarchy. That's a super system component. Yes, that was what Dhanoti पूछ रहा था ना अभी. You can write it if you want to. I'm not stopping. No. Okay. So in the component analysis, when we are identifying system components, then those system components have to be at the same level of hierarchy. But super system components can be at a different level, or will be at a different level actually. Can be, maybe. Yeah. So gravity is a super system component. It's a field. No, because super system components will also interact with your components. So you have to show the interaction of those super system components with your system components also. Has to be in the same table.
So for example, tabs parts are interacting through pen.
So through pen. So you say, are they touching themselves, each other? If they're not touching, then the answer is no. So as I said, in our language over here, interaction means plus means touch. If they're not touching, nothing. So should we review? So that is no touch. Direct touch is touch. जैसा भी हमने कहा कि hair dryer doesn't touch water. Hair dryer touches hot air. Hot air touches hair. एक बार देखें. Is it okay? So in this, I have not used gravity. You can use gravity. You can, again, the list. Super system is a huge list. You can make it as big as possible. But what I've done is I've used all the components: float, lever, switch, motor, pump, barrel, paint, tank, and parts, radiators, and then air also. Air is important because air is a part of the problem. It is in the presence of air that paint solidifies. Otherwise, अगर air नहीं होगी तो paint solidify नहीं करेगा. Reaction नहीं होगा, वो solidification वाला काम होगा नहीं. तो air इसलिए therefore I have not put gravity yet. Though gravity is also there, I've identified it as a super system component. So when we go further, we will see that there is a way to handle such big super system components also. But we can see. So now look at it. You will see that the entire chain, lever touches float, lever touches switch, that's it. Lever doesn't touch anything else. Tank, yes, but remaining motor, pump, blah, 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 no touch. Tank पे तो plus लगाया. Then switch, it touches the lever, it touches the motor, and yes, it touches the tank. Float touches the lever, the paint, and the air. Switch, हाँ, तो लीवर फ्लोट को टच कर रहा है. स्विच कहाँ टच कर रहा है? एक मिनट. Switch is not touching the float. The float, there is this lever is closing or turning on the switch. ये ऊपर जाता है, नीचे जाता है.
Sir, lever is not touching the paint in a way like when the float dips in. So the whole covering of the float.
No, lever is not touching the paint.
Lever is the rod which
Float is the only thing that is dipping in the paint. Lever is not touching the paint. Okay. Then pump के लिए, pump does not touch the float, does not touch the lever, does not touch the switch, but it touches the motor, it touches the barrel, it touches the paint, and yes, it touches the air. So आप जब gravity का लिखोगे तो आपको gravity भी दिखेगा, सबके साथ plus 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 आ जाएगा. I've shown that with the air thing. Is that okay? So for so many super system components like air, gravity, this will become plus 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 plus. Is that okay? So parts, radiators, for example, they touch the paint and they touch air. How is the switch touching the motor? Okay, let's look at it, because switch turns off the motor. The switch, wire we did not identify as a component. So this is a nuance. For example, I say that I'm interacting with you. I use this term, I'm interacting with you, but am I touching each and every one of you and interacting with you? No, but still we are interacting. So because I have not put light and sound as fields in my model yet, I can say that we are touching each other through those media. But I'm not interacting with someone in the other room because they're neither able to see me not able to hear me.
In this case, would it be better if we identify bias?
You can. You can.
Then so that also we the top and booker are also have contact with the right.
So again, yes, they will start to become interacting with each other. Okay. So interaction matrix जितनी simple लगती है, उतनी simple है नहीं. All that we need to do is put a plus and a minus. Now, all of you have your interaction matrix with you. Can you just check if it is symmetric across the diagonal? Just check once. Is it symmetric across the diagonal? All the pluses, just check that they are at the equal distance from the diagonal on both the sides. Wait, that is a sanity check. As soon as you come, so when you do that, that is one sanity check of the interaction matrix. See, you suppose you forget to put some extra, or you put some extra plus or an extra minus. In the next step, there is one way to handle it. But if you do not do the sanity check on the matrix, ki idhar plus lagaya, udhar minus lagaya, then there is a risk that you may miss something important in the next step. So at least this sanity check you should do. Then some extra plus is coming, we will see, oh, it ho hi nahi raha interaction. You can go back and remove that into a minus. Or some interaction is happening, you did not identify it, and you say, oh, it to tha. Let me put a plus there now. There's something you can do, but agar ye mismatch ho gaya, then you will not know. So this consistency you have to ensure. The sanity check you have to do. Is it okay for every one of you? It is not required to be okay. This is the first time you're doing something like this. Galti bhi hai to kuch farak nahi padta. Important thing is to learn. To know that this sanity check is sacrosanct. This has to be ensured. Okay? Once you've done the check, just raise your hand, I will know. Okay. So if I want to now summarize what interaction analysis is, so interaction analysis is a part of function analysis that identifies interactions between components included in the component model. The outcome, the output of an interaction analysis is an interaction matrix. What is that interaction matrix? It is a table that identifies interactions between components of an analyzed engineering system and its supersystem. So, answer to the question that was asked, do supersystem components need to be modeled here? Yes. They have to be a part of the interaction matrix because the system is interacting with the supersystem. Is this clear? Any questions? So then we now jump into the third step, which is called function modeling. Okay, no more questions here? Interaction analysis is actually simple, but it is not as simple as it appears to be. Conclusion क्या है? Matrix बनी आपकी. You have a matrix at the end of interaction analysis. Component analysis का conclusion क्या था? You have a list of components. Then you use those list of components to build an interaction matrix. Now we will do the function modeling. Because until you've done this, you can't do function modeling. Okay? So what is function modeling? Function modeling is a stage in function analysis where the function model of an analyzed system is built. ठीक है? ये साधारण इंग्लिश में बात हुई. A function model describes the functions, their usefulness and performance level, and costs of the system and supersystem components. Lot of keywords over here. So we're talking about a function model. What is a model? Oh, that person who walks on the ramp, that is a model. Yes, that is a model. Why? What is the role of that model?
Yes, ma'am.
It is, उसको आप देखते हो तो आपको लगता है I will be when I walk wearing that dress, I will look like this. Is it not? So a model is a dummy, is an emulation, is a representation of the original. Why do you make a model? Because it is easier to handle, it is simpler, it does not, it removes a lot of fluff. See, all the models are so slim, size 0. You are different, but the models are all size 0. That's what the female models. If you look at the gents models, they're also muscular. You are thingy, but you still see, okay, good. I would want to wear that shirt. So model removes a lot of distractions from the system. You're focusing on the real thing that was built. Okay, that is the real crux of the matter, is what you focus on. That if I was well built like that model, I would look good in that shirt. The problem is I'm not that well built. So whether I wear that shirt or not, I'm going to look like this only. But a model still has its role. We use models everywhere. Not those models, but we use models of systems everywhere. When you simulate something, what you do, you essentially create a model of that system. When you create Figma prototypes, you are creating models of the website or the app or whatever we are talking about. So models are representations of the original with a lot of unnecessary stuff removed so that we can analyze it threadbare. We can, in this case, we want to analyze it threadbare. So a function model is a representation of the engineering system. Why is it as a representation? And why is it called a function model? Because it describes the functions that are happening inside the engineering system. Now, what is a function we will come at? It's not the party wala function. आज मेरे घर पे function था. Not that party wala function. It's how. So अभी हमने कहा which items are interacting. The function is how are they interacting? What is the interaction? For example, जब हम bottle की बात कर रहे थे, तो we said that the temperature of the water is maintained. मैंने 50 डिग्री का पानी डाला तो 50 डिग्री का रहे, तो maintenance is a function. So what is the purpose or what is the interaction like? What is the interaction about? What is the verb that is coming into picture? Then their usefulness. Is it useful or is it not useful? For example, when the air and paint interact, they solidify. The paint solidifies. When it solidifies on the radiator, it is useful. When it solidifies on the paint, it is not useful. It is harmful. So the same function, air solidifies paint, could be useful at some place, could be harmful at another. And this is clearly described in every interaction, that this interaction, this is a useful function, that interaction, this is a harmful function. Your function model includes that kind of information also. Additionally, your function model also contains information about the performance level. हम lower hair dryer की बात कर रहे थे. So function model would tell that, okay, the heat that it radiates or the temperature of the hot air is not sufficient. So it is lesser than the desired performance. The amount of hot air I wanted to throw, it is not sufficient. I wanted a stronger blower in there. Performance level also is a part of your function model. Then costs. Like, is this component a part of, is this a target? If it is a target, you can do nothing to it. It is a part of the super system, and this is why the system exists. It has one level of cost. That function has to be maintained. But if it was something between the two components of the system, that function has lesser priority. Look at it like this. In this class, let us say we have two TAs. The target of this class is you, the students. The objective is that the learning outcome should increase for you. And there are two TAs. Now, the instructor and the TAs work together to ensure that the learning outcome is achieved. Learning outcome is the highest priority. Now, amongst the TAs and the instructor, who makes the question paper, who checks the question paper, that is not as important. Is it right? Now, for you, the grade is also important. So who gives the final grading? That could be important. But who checked the paper may not be. So the cost or the value of functions is also defined in the function model. Is that okay? So, अभी थोड़ा सा भारी भरकम लग रहा है. Don't worry, we will go through the process and we will learn it.
It's very complex. In a way,
Function modeling is? Yes. So in engineering, so हमारा पूरा जो inventive problem solving का process है, इसमें everything is relevant, is context oriented. आपने जब component analysis भी करा, तो until you asked what problem am I solving, you could not do the component analysis. है ना? Those of you who did not take the context कि okay, a hair dryer I would use like this, you forgot to use the user there. You forgot the hair there. To which Rohit said, मैं तो हाथ गर्म करने के लिए यूज करता हूँ हेयर ड्रायर को. हमारा बड़ा कुछ हो रहा है. So, you see, it is always context driven. All this analysis, whether it is function analysis, interaction matrix, or component analysis, components ही आपने अलग choose करे, तो interaction matrix change हो जाएगा. है ना? Is it okay? Is it okay? So, now, हमने function analysis कहा, telling that we are going to model all the functions in a system. So what is a function? A function is an action performed by one component to change or maintain the parameter of another component. A function is an action performed by one component to change or maintain a parameter of another component. For example, flame heats burgers. Flame is one component of that system. This is a barbecue. Flame is one component of the system. Burgers are another component of the system. What parameter does the flame change? The temperature. So I could also write the flame raises the temperature of the burger. So if nothing else, I can use that. Which parameter is changed? I can just describe that. Otherwise, raising the temperature, the common English word is heat. So flame heats burger. But अगर आपको common English word नहीं याद आ रहा, you can be very, very technical and you can say the flame raises the temperature of the burger. Okay? Now, flame over here is called the function carrier because it is performing the function. And burgers are object of the function because their parameter is either changed or maintained by the function. Is this clear? Flame is called the function carrier because it is the doer. Burgers are the object because their parameters have been modified or maintained. Clear? I'm trying to use as simple English as possible, but this is a different language. So you need to be careful, alert. Okay. So now there are some rules for a function to exist. A function takes place when the following three conditions are satisfied. Both the function carrier and the object of the function are components. So आपने उनको components की तरह identify करा हुआ है. If they're not components, you will not be able to model it. Okay. Second, function carrier interacts with the object of the function. If there is no interaction, if there was a minus in the interaction matrix, the function cannot exist. Is that okay? Then, parameters of the object of the function change or are maintained as a result of the interaction. अब सब लोग ऐसे. So, the first rule says that a function can exist only between components of a system or a super system. अगर आपके component analysis में कोई component exist ही नहीं करता, आपने अपने component analysis में Saturn डाला ही नहीं, तो Saturn का role and his girlfriend getting to know what is happening to him over here in the class is not there, non-existent. Are you with me? But if you had put Saturn, हम कहते हैं हाँ इसकी 7.5 चल रही है बेचारे की. You could have said this. Am I right? But I have not put it in my picture, so I cannot make that function in my function model. So to have a function exist, both the function carrier and the object have to be a part of the components of my analysis. Then the second very important aspect is they should interact. They should touch. If the lever doesn't touch the paint, the lever cannot act on the paint. The lever cannot act on the pump because it doesn't touch the pump. It can only act on the switch. The switch acts on the wire or whatever. Are you getting it? So, interaction is a necessary condition for a function to exist between two components. Third is that as a consequence of the function, either the parameters of the object should be maintained or they should be changed. Then there is some sense of defining a function. Na? See, I am working somewhere, you are working somewhere, we are sitting, we are able to see each other also if we raise our heads. Let us say we are sitting in the library. We are able to see each other also, but so what? या तो मैं नैन में टक्का कर रहा होता. But if I am studying, you are studying, two different tables, same table also, does it matter? No. So if nothing is changing, neither nothing is maintained, neither are you helping me study, nor are you helping me or dissuading me from study. There's no change in action. आप वहाँ हो चाहे नहीं हो, मेरे को फर्क नहीं पड़ता. There is no function happening. I rather not model it. I can model it, but there's no point. I will just make my analysis more complex. I rather not model it. Is that okay? So the hammer moves the nail. That is what a hammer does. Hammer moves the nail. What could be the alternate formulation of this function? The hammer changes the position of the nail. Now, changing position is in common English called as move, so I've used the word move. Again, I'm repeating this. At times, you may not be able to identify because, see, यहाँ पे हमने an example बड़ा simple लिया है जहाँ पे एक English word exists करता है. When you will talk of the problems that you are working on, You might not know what is the correct technical term. Don't get bogged down by that. Talk about it in terms of which parameter is either changed or maintained. It makes it far easier. What is important is to record whatever you know or whatever you understand about the system accurately and correctly. Is it okay? So a hammer moves nail is a function. What is the function carrier? Hammer. What is the function object? Nail. And the function is moving, represented by changing the parameter of the nail, position of the nail. So what is the function of an open door? What is the function of an open door? Huh? To let things go in and out. Okay. Is the child touching the door? So can there be a function between the child and the door? So Dhanuj is saying there is no function of an open door. Yes. There is no function of an open door because an open door doesn't touch anything. If that door was not there, even then nothing would have changed.
There could be an interaction the door and the air flow.
Fine, but वो ना होता door तो भी वही air flow हो रहा होता ना. There is an interaction, but there is no function. This is the nuance. Interaction may happen, but there could be no function between them.
Identified air as a component.
Fine. Yes, air and door are interacting. But what parameter of the air is the door changing? Or maintaining? Is the door changing that? Or is the air naturally doing that? The door is open. If the door was not there, would that have happened? If the door was not there, would that have happened? No.
It doesn't depend on the door.
So there is no function.
So if there is, suppose there is no electricity in the house and we open the door and it lights up the room.
Okay. So,
Then the door is fine.
see, a closed door has a function. It stops light from coming in. A closed door has a function. It stops light from coming in. It stops air from coming in. It stops people from coming in. But an open door has no function. An open door is as good as no door. Are you able to see this? It's so difficult to fathom. अरे यार, फिर door ही नहीं लगाना है क्या? No, closed door has a function. When the door is closed, there is a lot of function of that door. So you need the door. But once you open the door, then there is no function that this is doing. And once you realize that, you would say, oh, then the opening mechanism can be such that after that, the door doesn't take any space. Because there is no function. Collapsible door. But if you imagine there is a function of an open door also, then you will not be able to remove the door. Are you able to see this? See, suppose door had a function. Suppose the open door also had a function where I would say that, okay, this knob, I am connecting with something else. And if you try to close the door, that machine gun will start to shoot. Then that open door also had a function. But what was happening? That open door was touching that string. That function came because that string happened. When I'm using the open door like this, then there is no touch that is happening. There is no function. Are you able to see this? To have any function, touch, or interaction is necessary. To have any function, even if the touch happens, for example, air does touch the door, there is no function because it doesn't change any parameter of the air, neither does it maintain any parameter for the air. Are you able to see this? So all the three conditions have to be met for a function to exist. If any of the three conditions is not there, a function is not there.
For example, some flows are hanging behind, and when it is closed, they are still hanging, and when it opens, they are still hanging. So it is interacting with, and an open door is interacting with, but it is not taking any parameter of.
No, it is maintaining. But again, then the clothes should be there, which are in touch with the door. है ना? वहां पे इंटरैक्शन आ गया तो फंक्शन डिफाइन कर पाऊंगा मैं, क्योंकि क्लोथ्स आर टचिंग द डोर. Or are maintained. Careful. Bracket में or are maintained. Every word is important. We are talking technical over here. Might sound like English, but it is not English. It is technical.
So what if door opens and it closes some other?
So then it is a closed door for something else, and there is a function with that, but not with this. पाथ मेंटेन कर रहा है. अच्छा, अब अगर मैंने उस रास्ते में इसको बिठा दिया, बेचारा बाई चांस जब भी बात होती है सामने आ जाता है. चलो इसको बिठा दिया, अब रास्ता रुक गया. ओपन डोर ने क्या मेंटेन कर लिया? ये बैठ सकता है ना वहां पे जाके. क्या मेंटेन कर लिया ओपन डोर ने? Do you see that?
कुछ भी आ सकता है, तो
I have to make him the component of my system. I have to make him the component of my system, and then that could violate. Super system component and is a part of my analysis. Open door is not maintaining the path, by the way. It is not doing anything to the path. Neither it is maintaining it, nor is it creating it. Path was there, and उसको maintain करने के लिए आप उसकी सफाई करोगे, वो कोई और करेगा. Door ने कुछ नहीं करा. कुछ भी करना है तो something else is actually coming into picture. An open door has no function unless it is, जैसा मैंने कहा कि आपने उसको ड्रॉस्ट्रिंग लगा के एक कंट्रोल करके मशीन गन टक 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 सबको उड़ा दूंगा, कर दिया. Is that okay? Sorry? Physical, chemical, कुछ भी, magnetic, कुछ भी हो सकता है. If I'm changing something, there is some interaction, some impact happening.
Switch or motor to the component. So that
So he's saying the switch and the motor, they are two components which are interacting, but the switch does not do anything to the motor, does not change anything for the motor. So there is no function. Are you sure there is no interaction, no such thing? The switch turns on or turns the motor off. तो फिर आपने वायर नहीं बनाया अभी. आपने वायर को क्यों नहीं बनाया? बिकॉज आपने कहा वायर इज जीरो रेजिस्टेंस, एंड जीरो रेजिस्टेंस को मैं इलेक्ट्रिकली टच मान सकता हूं, तभी नहीं बनाया आपने वायर. Then they are touching. If we take the wire, then you say that okay, this sends the signal through the wire, and that wire takes the signal to the motor, and then that wire turns the motor on. Wire is a component then. Wait. Function model is about interaction between components.
Then if there's a component middle, like wire is a component of switch, wire and
Switch has no direct function with the motor now, because you have modeled wire also as a component. Switch is a component. There is no function between switch and motor in my function model, because they don't touch. Because you said wire is zero resistance, I can assume that they are touching electrically. Therefore, you had put plus there. If you plan the wire, then it cannot do anything to the wire. And to the switch cannot do anything to the motor. So it will simply say it sends current through the wire. It activates the wire, or it changes the flow of current in the wire. Then when the flow of current changes, it controls the motor. The wire controls the motor. It is controlled by. So you've heard this term drive-by-wire. So for automotive, for self-driving cars, where you have a driverless thing, you say drive-by-wire. So what is happening? Microcontroller through wires is controlling the steering, the acceleration and everything. So that is drive-by-wire. Also call it autonomous driving, but it is also called drive-by-wire because wires ke through hi sara information transfer hua. You can do that. So wire can be modeled, and if you model wire as a component, then wire is controlling the motor, not the switch. But if you don't model the wire, you say wire is zero resistance. So these are effectively in touch. You make your model simpler, and you say, okay, switch controls the motor. Are you with me? Yeah. Control करा ना, कभी on करा, कभी off करा. Electrical. ठीक है? So, what is the function of a helmet? Huh? To protect the head, to save the head, and provide safety, not to pass the bullet. All of them are wrong. So what is the real function? To deflect the bullet, to stop the bullet. So in function definitions, you do not use any declarative verbs. Protection is declarative. For her, protection may mean something else. For you, it may mean something else. It is subjective. Different people may construe different things out of a declarative verb. When we are making engineering models, we are prohibited to use such declarative statements. Is that okay?
In this case, we should know what kind of template we are talking about. Is it a memory aspect or that?
Okay, मतलब ठीक है. Even if you were talking about a regular helmet in a car, you cannot use the word it keeps the head safe. Protect is a declarative statement. A function is defined between two components. So to protect the head, helmet protects the head. Helmet is a component, head is a component. But you said to save from injury. Is injury a component? Function doesn't exist. That is not the right formulation of a function. Protects is a declarative verb. I repeat, protect could mean so many different things. Clean could mean so many different things. है ना? सबके घर का cleanliness का standard अलग अलग है. Enter into a boys hostel room. The inhabitant says, "कितना साफ कमरा है?" And मम्मी आती है, "क्या कर रखा है? तुम्हारे हिसाब से साफ है, किसी और के हिसाब से अभी भी गंदा है." अब सब नॉड कर रहे हैं, हाँ होता तो है. So declarative statements cannot be part of your function model because they can be interpreted very differently by every different individual. You have to choose a language which is non-declarative.
So can this is safeguard?
No, safeguard is same as protect. Deflect the bullet. So to cushion the interaction, to act as an intermediate between the impact of ground and head. So what you would say then is that it dissipates the energy.
So instead of a generic statement, we make a specific statement of
Yes, the exact function that it does.
that
नहीं, इसलिए मैंने कहा dissipates energy. Why? If I say stop the bullet, I can say that it was coming at velocity x, and the parameter of the bullet changed from velocity x to 0. And I can measure it. Deflect, it was coming at an angle x, and I changed, it is now going at an angle y. I can measure it.
Also say change the path of the
You can say the change the angle at which the bullet moves. That is same thing. Deflect. Deflect is an English word to represent that. It is not declarative. So declarative का मतलब जिसको आप measure नहीं कर सकते. Clean. How do you measure clean? You may use a different scale. I may use a different scale. But angle, when I say deflect, this angle is a geometrical term. I understand. Velocity is a physical term. I understand. Okay. So no declarative statements. Yes, Pritha. Yes, we have to define the carrier of the function, the object of the function, and the action, which cannot be declarative. Is that okay? So we'll stop here. We'll continue from here later. Yes, Dhanaj.
different sub-function models or different functions, and where different components are interacting with your like it's a complete out.
So you're talking about a hierarchy of function models. So they will have to be at a different hierarchy of components then.
So like for example, the tan example, you can be considered the whole as a function model.
As a function, as an engineering system, or you do another engineering system, and that could be a daughter function model there. So wait, don't rush. We're not proceeding further with the slides over here, but there is an assignment that I want to give you. I want you to clearly think of one interesting problem that you would want to solve as a part of this course. This problem could be a part of your thesis project. This problem could be a part of, it could be some generic problem, जैसे VD sites की बात कर रहे थे हम. It could be any problem. I want you to think of one problem. You can think of it as individual, you can think of it as groups. And in the next class, you will be presenting that problem for 2 minutes to the entire class. Okay? When you will be presenting that problem, I will evaluate if this problem is good enough for us to understand and use different concepts that I'm going to teach in this course. Is it okay? Because it could be a very good problem, it could be very close to your heart, but if we cannot apply TRIZ on it, I do not want you to use that as your course project, because then you will struggle. So we want to move towards your course project now. So in the next class, I want you to identify one problem that you want to work on. Typically, if the problem is fairly complex, doesn't have an obvious solution, that is a good problem to work on. Okay? In the last uh, cohort that I had with this particular course, because people chose problems which were interesting enough, 3 teams from that particular cohort went ahead and published their work in the International TRIZ conference that happened in Dubai last that time. Okay, so we can check where the International TRIZ conference is happening this year. But what I'm saying is that if you choose an interesting problem, and they also filed patents, by the way, 2 of them. So if there is an interesting problem, it could lead to this one particular course can lead to patents and publications coming your way, just like that. Is that okay? So it is important that you spend some good time to identify a problem. So I can share with you the kind of problems the last cohort worked on. So one team worked on, so one team had a person who had already, before joining IIIT Delhi, after their BTech, worked with a engineering company where one problem that they had seen was that जो vending machines होती हैं, इनका जो glass होता है, in moist, in humid conditions, water droplets come on it. So you're not able to see the items placed inside the vending machine. And when this happens in big chains, or say, for example, Big Bazaar or somewhere, and you're not able to see that there are cheese slices kept there, or there are some stuff kept there, then the sale of those products reduces. See, a lot of purchases in a mall or in a shopping complex happen because of impulse. Oh, दिख गया, याद आ गया, and I will pick it up. दिख ही नहीं रहा तो याद नहीं आया तो sale कम हो जाएगा. So that was what was happening. So there was a requirement to come up with a solution such that the sales increase. That was the goal. The problem we know, the sale has to increase. This was one thing. Then there was another team that worked on. So there was this person's mother was working with a medical devices company, and they were making those machines. So pharmaceuticals, जब tablets बनती हैं, pharmaceuticals बनते हैं, तो they have to be kept in complete vacuum. Okay. So there is one clean room where the chemical reaction happens, the tablets are made, then they are turned into doses, and then they are put in another clean room. So some transfer has to happen. Okay. And this transfer, the outside clean room is not as good as the inside clean room. When you transfer the material from one place to the other, you want the medicine to be still intact. Okay, it should not get impacted. So that was the second problem that was published. The third paper that got published was about a memory cell, where they said that this particular memory cell needs to operate at this particular voltage and time and this. So it was a stretch to get that paper in there. But since we were using all the TRIZ principles and everything, that could get published. Okay. So it can be something that is directly relevant to your project. It can be some other problem which you know. So discuss with your parents, discuss with your friends, what is the problem which you know is very difficult. Just look around, and who knows, we may come up with an interesting solution, and we could also protect it, patent it, or at least publish it. Is that okay? So in the next class, I want all of you to present either as 1 person, 2 person, 3 person. So no project team is more than 3 people. Is that okay? 3 people is fine. So at most 3 people, and present. आप individually भी present कर सकते हो. अगर आपकी टीम नहीं बनी है तो आप 3 लोग मिलके भी एक topic present करोगे. I may simply say, no, this topic, this problem is not good enough to be used in the project, because you will not be able to use the tools that we are going to learn. Now, you don't know the tools yet, so you don't know which problem is right or not. You just identify interesting problems that you would be motivated to find solutions to. So for this first guy, he was motivated because he had already touched that engineering problem, and he was like, "Hey, solve nahi ho rahi thi tab, so let me try TRIZ on it." The second guy, उसने मम्मी से पूछा अपनी, तो उसकी मम्मी ने कहा कि हाँ, this is very complex, this is not easy. So if you can solve this, this could be interesting, and we could use it in our company also. So they are using it in their company. Third one was a PhD student who picked up the problem, and they said, okay, I would want to do something about my PhD topic itself. So You should be interested in solving the problem. That is the most important thing. If you are not interested, then don't talk about it. Okay? But that is what we will do in the next class. And then from the class after that, we will continue with the function analysis. And subsequently, while we are doing the classwork or the assignments, you will also be working on your problem statement together as a team. Okay? So we now move, it's kind of changing gears now. Okay? All the best. Sorry? No, you don't know if the solution is there or not. You don't worry about that. You want a solution to that problem, and we will see if this problem can